All right, so now we're going to take a look at converting between units. There are two ways that you can convert between units. I actually do not prefer this first way that we're going to take a look at. I prefer the second method that we're going to take a look at. But nevertheless, there are two ways to do it. The first way is that we can take the prefix out. Okay, so you have to have the prefix table memorized for all of those units and what they correlate to for in terms of numbers. Okay, so you have to have that table memorized. So we can take the prefix out and just use scientific notation only using the base unit. So that's like the middle of the table, either seconds, grams, things like that, liters. Okay, so we're taking a look at this first example here. We're going to convert 1,245 kilograms to grams. So gram is the base unit, okay, and we're going to take the kilogram out and use this number in terms of the base unit to rewrite the number. Okay, all right, so what we're going to do is we're going to say, okay, kilogram, kilo is 1,000, that's 10 to the third. Okay, and I'm going to take this number and I'm going to put that 10 to the third right here, this number times that 10 to the third. So now I've taken out the kilo and replaced it with that, and that corresponds to the base unit of gram. Okay, so now it technically is correct, except we don't have it written in the correct scientific notation. So I need to write this number less than 10 and greater than 1, right? Okay, and so I'm going to move the decimal place over here between the 1 and the 2, and so that's 1, 2, 3. I moved it over 3 spots, so I need to add on an extra 3 here for this exponent. So the number is 1.245 times 10 to the 6th grams would be. Okay, so the second way that we can convert one prefix to another is using something called dimensional analysis. And this is the most common and usually the preferred method in order to do conversions that take place in a mathematical problem. Okay, so dimensional analysis is using units as a guide to solve problems. Okay, the units should always be included in the calculations. You can't stress this enough. Any teacher that you've ever had or will have will always stress the importance. You have to show the units. It helps you keep track of where you are in the problem and if you have completely converted to the correct unit along the way. So please always try to get in the habit of including the units in your calculations, because the units are multiplied and divided as well as the numbers are, and the units will cancel out accordingly. Okay, just like any other algebraic quantity. Okay, so we can use a unit and it can be converted to another by using a conversion factor. So as long as you have a conversion factor from one unit to another, then you can convert the unit. Okay, so this is kind of our general plan here. You're going to take whatever units you got and you want to convert them to the units that you want. So I always kind of, when I learned in high school, I have my gots and I want to get them to my wants. Okay, so this is kind of always stuck with me. And so how do we do that? We have a roadmap that we're going to kind of outline the units that we can convert from one to the other. And those are our conversion factors that we're going to put in for the calculation there. Okay, just for an example, we have just kind of like a one-step example. We have a got unit, whatever the unit is that we're given, that we're starting with, and we want to go to some other unit that we want. We need to have a conversion factor that the got unit is equal to the want unit by whatever that measure is. Okay, so I'm going to put the got units on the bottom and the want units on the top. So then this is like a got over a got, which is like 1 over 1 or 10 over 10, okay? And when you multiply that, it's equal to 1, and so then they cancel out. So those cancel out, and I end up with my want units. Okay, so we take a look at several different problems here. We'll go back to that very first example of the 1,245 kilograms convert to grams using dimensional analysis, and then we'll hit up a bunch of other problems that you'll have a little worksheet that you can work through as we complete them on the video. Okay, so going back to that very first example we did for the first method that you could use to convert between prefixes, we're going to use the same example for the dimensional analysis. Okay, so we have 1,245 kilograms, and we want to convert that to grams. Okay, so these are my GOTs. I got GOT kilogram units, and I want gram units. Okay, so I need a conversion factor between kilograms and grams, okay, to go to that unit. All right, and so if I don't know the conversion factor, then I need to look it up or find it. Since this is a prefix unit, then it's one of those that's on that table, and I already have that memorized, right? Usually homework problems, the conversion factors are not provided, but in your textbook, the very back portion of it, you got some conversion factors back here that are usually helpful. Other times they may be provided to you on an exam and things like that. Okay, so you have to have a conversion factor. If you don't have it, you need to look it up or figure it out. Okay, and I always ask which unit is smaller. For example, if we're looking at prefixes in particular. Okay, which unit is smaller, the kilogram or the gram? Well, the gram is the base, so it's smaller than the kilogram, which is above on the table. And so I'm going to need a lot more of the grams than the kilogram. So the prefix for kilo is 1,000, so the 1,000 goes with the gram because I need 1,000 of the grams to equal just 1 of the kilogram. Okay, so this is my conversion factor here, and I'm going to set up, here's my GOTs. I need my conversion factor here. I'm going to put my GOT on the bottom, so my kilograms, as kilogram over kilogram, it cancels out, and my ones on top. So 1 kilogram on the bottom, 1,000 grams on the top, and I just multiply 1,245 by 1,000. These cancel, divided by 1, and I get that same number that we previously got from the other calculation. Okay, so now we're going to take a look at some example problems for converting. Here we have 50 grams. We want to convert that to how many micrograms are in 50 grams. All right, so that's what we got. We need our conversion factor to get to what we want in micrograms. So we're going to look at our prefix table. Okay, grams is the base unit going to micrograms. That's going to be on the bottom of the prefix table. And so we can kind of know that conversion directly. We have 10 to the 6th micro, a million. Micrograms is the smaller unit, so I need more of them to equal 1 of the larger unit, the gram. So that is our conversion factor. We're going to put our grams on the bottom to cancel for our conversion factor. We end up with our micrograms on top. Grams cancel, and you multiply 50 times 10 to the 6th, and you get 5 times 10 to the 7th micrograms. Okay? And the next example, we're going to convert 10 nanograms to kilograms. Okay, what you want to pay attention on this one is nanograms is a prefix that is on, nano is on the bottom of our table, our prefix table. Okay, kilograms is on the top of the prefix table. Where's that up here? Kilo is on the top. All right, and so we're going to be crossing over that base unit, and it's always best, I always do it myself. Anytime you're crossing a prefix going across to the base part of the prefix table, I always stop at the base unit before I cross over to the other prefix. And that always keeps me sure that I'm not going to miss an exponent somewhere that I need. Okay, so what we really need to consider is our roadmap. We're going to go from nanograms, we're going to stop at grams. We're at the bottom of the prefix table. We're going to stop at the base unit of grams, and then once we go to grams, we're going to cross over to kilograms. Okay, and so I need a conversion factor between nanograms and grams, and so nano is the smaller, nano 9, that's how I remember it, right? So 10 to the 9th nanograms, I need a whole bunch of the small unit to equal 1 of the larger 1 gram unit. Now I'm at the base, so that's going to be my conversion factor I can put in right there to get to my grams, and now I need a conversion factor to go to grams to kilograms. Okay, grams is the smaller unit. I need 1,000 grams to equal 1 kilogram. So that's going to be my conversion factor to go to the final unit there. Okay, so here it looks down here for the math. We have 10 nanograms. This is our first conversion factor, the one that we had up here. Put my nanograms on the bottom to cancel those out. So I have 1 gram on top. All right, and then my second conversion factor, where I'm going to go, so here we're at right there. Okay, so now I'm at grams. I want to go to kilograms. So this is my second conversion factor here. And I want to put my grams on the bottom to cancel out with these. So 1,000 grams on the bottom, 1 kilogram goes on top. That's my final unit I want to go to. The grams cancel, the nanograms cancel, and I have kilograms in my final unit. In my calculator, I'm going to put 10 times 1 times 1 divided by parentheses 10 to the 9th times 1,000 end parenthesis, and that is my number there, 1 times 10 to the minus 11th kilograms. Okay, so you're just going to multiply the numbers on the top, and then you're going to divide by the numbers on the bottom. Again, you need to use parentheses accordingly. All right. Okay, so the next example, we're going to take a look at converting 1 milligram to nanograms. So how many nanograms are in 1 milligram? Okay, so what we're going to first recognize is that milli and nano are both on the bottom portion of the prefix table. They're below the base unit. Okay, so you don't necessarily have to go up to the base unit and then back down because you're not crossing over that table, which is what I would highly recommend you do, is that you do stop at the base unit if you're crossing from the top to the bottom or bottom to the top of the table. However, sometimes when you're first learning the prefixes, you might not be confident in the factor difference between the prefixes on the bottom or the factor difference between the prefixes on the top. So sometimes it's good to go, if you're on the bottom, to go back up to the base and then back down to whatever that unit is that you know that prefix value for, or same thing on the top of the table. You can be in the top unit, go down to the base unit, and then back up to the top because you have that prefix memorized. There is a conversion factor directly between milli and nano, but you might not realize, and that might not come to you very easily when you're first learning them, okay? All right, so this first way that we're going to solve this problem is we're going to go up to the base unit and then back down to the unit that we're trying to convert to, because it may be a little bit easier as you're learning the prefixes. Okay, so my roadmap here, I'm going to start with milligrams, and I'm going to go up to the base unit gram on the prefix table, and then I'm going to go back down to the nanogram. Right, so milli is million, that's 10 to the third, that's a, excuse me, milli is 1,000, 10 to the third, okay? So that is 1,000 milligrams is 1 gram. Okay, that's a smaller unit, I need more of them. And then I'm gonna go back down to nano. Nano is the smaller unit, nano 9. That's gonna be 10 to the 9th nanograms is 1 gram. Okay, so I have my conversion factors outlined here. Milli is 1,000, not a million. Micro is a million. Okay, I do apologize for that. Okay, so micrograms, 1,000 micrograms is 1 gram. 10 to the 9th nanograms is 1 gram. Okay, so I'm just going to put my conversion factors in here. I'm starting with 1 milligram. So my milligrams are going to go on the bottom per 1 gram. All right, so I've gone up to the base unit. I'm at my grams. Now I'm going to go back down to nanograms. So I want to cancel out my grams. So that's going to go on the bottom with my 10 to the 9th nanograms on top. Right, each of these is equal to 1. Okay, and so that's why I can arrange them. I can flip them in any orientation that I need to cancel out the units that I want. I end up with my nanogram units. And I can just do this in my head, right? So 10 to the 9th divided by 10 to the 1st, everything else is times 1. So exponents, when we're dividing, we subtract them. So I end up with 1 times 10 to the 6th nanograms, okay? All right, the other way that we can do it is we can say, oh, okay, I know that a milligram is 1,000 compared to a gram, And I know that a nanogram is a billion, 10 to the ninth, compared to a gram, right? And so I just need the factor difference between 10 to the 3 and 10 to the ninth, and that's what's going to be the difference between my conversion between the two nanogram and milligram prefixes. Okay, nano is smaller, so this factor difference between 10 to the third and 10 to the ninth is a million, 10 to the sixth, okay? And nanogram is smaller, so I would need 1,000,000 nanograms to give me 1 milligram, okay? And so I can kind of figure that out in my head without having to do this extra up here, okay? And so I could just set up my conversion like this. I just plug this conversion factor in right here, so my milligrams are on the bottom, and 1,000,000 nanograms is equal to that, and so my milligrams cancel and I end up with my nanograms. So you essentially have one less step if you're confident in figuring out the factor difference between the prefixes like that. Okay, it's completely fine to go up to the base unit, and I would highly recommend that you do that until you become very familiar and confident in that.